Our next speaker is Bill Moore from Xona. Xona is our gold sponsor, and we thank Xona for their support. Bill is the CEO and founder of Xona, providers of a unique zero trust user access control and analytics platform for critical infrastructure. Currently focused on helping global power, oil and gas, and manufacturing customers reduce their remote operations cost and cyber risks. Bill has 20 plus years of experience in security and the high tech industries, including positions in sales, marketing, engineering, and operations. Bill will share his insights on applying a zero trust framework to securing the oil and gas industry. Over to you, Bill.
Yeah, thank you very much. And thank you to the Oil and Gas Automation and Digitization Conference planners. I want to talk about applying a zero trust framework. And this is really a very popular marketing term now being used to better secure, from a cyber secure perspective, oil and gas networks, really any operational technology networks and assets that are out there. Obviously, in oil and gas, from upstream, midstream, and downstream, have lots of operational technologies and industrial control systems. So this is really going to speak to applying a more secure way from a user access perspective, remote operations to these critical assets. So the first thing I'd like to do is talk about what zero trust is not. Okay, so zero trust is not a castle and a moat. You don't stand outside the castle, outside the moat, and say a passphrase, Knights of the Round Table, and drawbridge comes down and you go in and now you're trusted. That's not zero trust. As soon as you're in the castle, you get through that first phase of authentication. You can walk around in rooms. There's no video cameras in there to watch you. So this is not a good example of zero trust. So I wanted to first kind of lay out what zero trust is not. So what zero trust really is, I think a good analogy for that between the castle and the moat is looking at a modern commercial office building. This is really kind of a great example, I think, of zero trust in ones that have very secure offices and things that need to be protected. So, the building itself, a lot of times there's a key card that you have to go in. So you multi-factor authenticate. Maybe it's something you have and you have to put in a PIN code just to get into some secure buildings. And then there's a guard desk who may also check your ID. Again, you go to the elevator. There may be certain floors within that commercial office building that you can't access without using a key fob again to authenticate to get to that particular floor. Again, once you get in the office, there's another level of authentication. Maybe you have a separate key to open up the office. And then you have a combination to the office safe that sits under your desk for the sort of the fourth authentication, if you will. So this is a good example of what really zero trust is. It's kind of check and balances all along the way from the time you're outside entering the building till you're opening that safe, on the office on the 9th floor, for instance. And again, there's surveillance cameras on every floor, outside the building. So there's a lot of ways of not only monitoring and authentication and authorization all along the way. So this is I think this is a good example of what zero trust is. And so I kind of want to lay that out because there's a lot of marketing around zero trust, and a lot of the marketing is around one aspect of zero trust. And I kind of wanted to lay this out to look at zero trust holistically from the moment you're authenticating into the building all the way to that safe under the desk. So I'm going to talk let's take this up to a 50,000 foot view and sort of talk about OT cybersecurity challenges in general. So when we talk about OT, we're talking about SCADA systems, HMIs, all of the systems, PLCs, and so forth that operate, flow control valves, all kinds of different technologies that would be in the oil and gas industry. And what's happening that's interesting in OT versus IT is there's a big digital transformation going on with the introduction of industrial Internet of Things. So things are getting digitized at the edge. And once things that used to be air-gapped are also being connected to IT networks. What's also interesting about OT versus IT is IT over the last 10 or 15 years has consolidated a lot of their digital assets into the cloud and into big data centers. And OT is actually going in the opposite direction. The edge is becoming more digital, and there's computing assets out at oil wells and different processes on pipelines, obviously, and refineries and so forth. So there's more and more sensors, more and more digitized compute assets and digital computers that are managing all of this. So this is actually expanding the attack surface. At the same time as things have been consolidating in IT, OT is actually becoming, the edge is actually becoming wider. So when we talk about OT and IT, when you try to take IT cybersecurity tools, which have kind of been built on one another over the last 10 or 15 years, there's authentication, there's VPN, VDI, multi-factor authentication, jump servers, all of these things have been kind of built up, and it fits very nicely when you have hundreds or thousands of users and hundreds or thousands of or hundreds or thousands of applications and systems, but it's way too costly and complex for OT requirements. And there's also requirements around OT, such as site level controls that add safety that you don't have to worry about in the IT world. So this is a big challenge in what we see in OT, in trying to bring the same level of security or even better security to OT than currently exists in the enterprise IT world. And again, as I mentioned before, a lot of this complex IT can make OT systems vulnerable. Misconfigurations when you have complexity happen. And again, a lot of these IT systems are older technology, and they don't do a very good job at protecting the OT network and isolating the OT network and the critical assets away from the larger IT enterprise and the internet. And again, they may not also meet the unique regulatory requirements that exist for OT. So how do we build a zero trust framework into OT user access? And when we talk about zero trust, I'm really going to focus on the user aspect of this. There's also kind of ways of segmenting networks and things like that, but I'm going to really focus just on the user access aspect of zero trust. So obviously the first thing, this is the thing that you must do for access to any critical network, really any network with any sensitive data as well, is multi-factor authentication. So in this obviously dovetails into a lot of the compliance objectives of IEC 62443, NERC CIP, as well as NIST 800-53 and the RMF within the US federal government. And then the second thing is we want to reduce the attack surface. And we do this through protocol isolation. So making sure that protocols that are used on the critical OT network are not bled out into the internet, into the IT network, because that just widens the attack surface. And then third, to have OT specific access controls. So granular site level controls, time-based access controls for maybe your OEMs or your other third parties, so you can control when they're accessing particular systems, and when they're able to either troubleshoot or patch those systems. You want to do that during a scheduled outage. And you also want to have the plant level controls to have somebody there on the other end also allowing the access to that system, just as another safety control. Again, that's much different than IT. You usually have somebody, giving you permission to access a SCADA, SCADA application in IT or a critical application in IT. It's usually just, you have privileged access management and things like that in the IT world. And that's it. You don't have these, a human on the other end giving explicit control. Again, the next part of this is not just user access logging, but having the recording of what the users are doing for forensics as well as public safety, to see, if there is an incident, maybe we can go back and maybe it was a mistake, go back and look at a video of the process or the inputs that were put in to the system from a human on the other end, again, having that complete user access recording is very helpful. Excuse me. And again, meeting regulatory standards, of course, is very, very important. So when we talk about implementing OT zero trust, and I'm going to kind of go through this step by step as part of implementing a zero trust framework. Obviously, the first part is OT authentication. And we talk about MFA, not all MFA is the same. So, using a hardware token is the most secure MFA, right? Followed by TOTP, which would be using something like a Google or Microsoft Authenticator application would be second. And then the least secure would be using SMS text messages. So you want to think about that when you're implementing an MFA. It's not just any MFA. You want to actually pick the more secure or the most secure way of doing MFA, right? Obviously, SMS text messages for MFA have been hacked, so that's something that really should never be used for MFA when you're talking about your most critical assets. Again, the other part of this too is that you have to be able to provide authentication for not just your employees, but your third parties, your vendors. So having a flexible vendor access management platform is also very important, because there's many times a mismatch in access methodology between your organization and your third party, maybe different types of VDI or VPN and VDI, so forth. So being able to do this in a frictionless, clientless approach using a browser is preferable. So you can bring your third parties on in a more efficient way and secure way. So we look at this kind of graphically, with utilizing a hardware token or TOTP, which is using a QR code with an authenticator app, time-based authentication. You want this to be flexible, because many large organizations, really in every industry, and oil and gas is no exception, they may have a combination of OT only enclaves, as well as wanting to be able to register through an IDP and IT and then head down into the OT network. So the ability to integrate with identity providers like it could be Microsoft Azure, ADFS, or Okta, to give you a couple of examples, or others that leverage SAML 2.0, for more modern IT to OT authentication. So this is one way of coming down into the OT environment. Again, according to CISA, it is recommended once you go down into the OT network, into the OT DMZ, and with the Purdue model, that's level 3 or level 3.5. You want to multi-factor authenticate again. That is a recommendation from DHS CISA to connect to the OT network. And again, being able to also have a complete logical user access layer without the need for a cloud or your IT network is also something to consider, because large enterprises usually have a combination of both of those architectures. Excuse me. So the second step is really about isolating the network, right? So being able to not let the most vulnerable protocols that you're using on your OT network bleed out to the internet and to the endpoint, the remote users, desktop or laptop. So you want to utilize, no data in transit. So not having the data communication protocol go outside of the OT network, because then there's no attack surface or protocol to use for an attack. So a good example of this is showing how using protocols like RDP or VNC, which are very common for Windows and Linux systems for remote control of those systems. The ability to stop those protocols from actually going out to your remote employee or your third party is very important. RDP, that data communications protocol, is the #1 attack vector for ransomware. So you never want to have your RDP protocol being exposed, definitely without a lot of other security controls in place. But it's a best practice, especially with regards to your most critical assets, to just not let that protocol leave your OT network. So, and the way we do this through our protocol isolation and user access segmentation is we drop the protocol itself and we bring back the screens of that HMI SCADA application to the browser of the third party, the remote employee. They can view it or operate that screen, but there's no protocol being exposed. So it's just images going back to the browser of the remote user. So, and again, this obviously needs to be encrypted, and you only want to expose one port out to these remote users, and that is an encrypted port 443. That's just the encrypted browser session that you would have in your browser. Okay, so the third step in implementing zero trust from a user access perspective is the asset authorization. So again, this is where the safety issues in your operations come into play. You want to have those additional time-based access controls, those plant level controls, virtual wait lobbies, things like that. So there's somebody in the control room at the plant that can give specific access before the user actually is operating or even viewing a system within the control room. So this is the best practice, is obviously putting these granular controls in place for authorization after they've multi-factor authenticated. So, and again, these are some of the granular controls. You want to be able to turn on access permissions to each individual connection or asset. So for instance, if there's a user that needs to access a particular HMI but doesn't need to access anything else, you can just turn on the access permissions for that HMI. And so when they multi-factor authenticate, the only thing that they will see is that one HMI, and they won't be able to see anything else. And then you can decide whether to enable file transfer to that system. So maybe they need to patch that system. You can turn on file transfer and make it unidirectional, saying, okay, you're allowed to patch this system, but you can never bring a file off of the system. So we're going to make this a one-way file transfer capability. We'll make it moderated, so somebody has to approve the transfer of that patch file. And then we're going to set up a time-based access control. So you can only do this in this 4-hour window that we're going to give you on a particular date. And then once that time window is expired, you no longer could even authenticate to the network. So this is, these are the type of granular controls that need to be implemented in an OT network. And with this purpose-built system from us, you can do that very simply. You don't have to integrate a lot of technologies to do this kind of simple, based authentication and authorization. So the fourth step really is about monitoring and logging and recording. So in some cases, you may want a senior tech to be able to look over the shoulder of somebody in the control room accessing a particular site. So you could be granular in terms of if they're able to write to a screen in the control room or just read the screen. So this may be something that the policy says, hey, we can have somebody remotely monitor, but we can't have them actually doing the interfacing with the system. So this is very helpful. Obviously, if you're troubleshooting a particular issue, to be able to have somebody more senior that maybe can't get to the site, looking over the shoulder of somebody in the control room and walking them through a procedure to alleviate an issue. So that's a big part of the monitoring. Obviously, for cyber forensics, you want the full access session logging as well as user access recording. So one of the things about the access recording is this is not just a cybersecurity thing for forensics. It can also be used for operational efficiencies, such as training for junior technicians, having recording processes, having somebody go through and do all those, and those videos can be viewed to train junior technicians on how to do different procedures. So this is kind of a screenshot of what that looks like. So you have the username, where they logged in from, the session time and date, the platform that they connected, whether it was a mobile device, a laptop, what the operating system, what type of browser they use, and then be able to access the logs or process a movie file. So basically, as the operations are going on between the remote user and that OT asset, we can record everything, and that recording can be processed into a specific type of movie file that can be played in a regular viewer. So this is just kind of an example of what that looks like. So again, those are the key aspects. So to kind of review, step one, going through the multi-factor authentication of that, going through the granular authorization and the time-based and access controls and so forth for safety, being able to have the access logging and the monitoring, and as well as the user access recording. Obviously, all of that is very important. So a little bit about Xona. We were founded in 2017. We're headquartered in Annapolis, Maryland. We have offices around the world. We have R&D in the United States and Michigan, but we have offices in EMEA, in Europe, in London, as well as in the Asia Pacific region. We are an OEM to major OT providers and integrators. GE uses us for remote operations for their power generation plants at global power plants. So we're deployed in over 25 countries now, not only in energy and oil and gas, but also in manufacturing, transportation, and the government as well. And that includes federal, state, and local governments. So again, thanks very much to OGAD for hosting this, and I'll turn it back over.
Thank you so much, Bill, for such an insightful presentation and sharing the information on Zero Trust framework. It was really interesting. So yes, we have one question from one of our audience. Given an organization is cyber attacked with ransomware, what are some methods to treat with such an attack?
Yeah, well, I mean, I think really the key here is having an incident response program. So we really focus more on putting together the platform to protect against those. But obviously, you want to have good cybersecurity hygiene, good tools for asset discovery vulnerabilities, understanding what's on your network is kind of the basic blocking and tackling. But really, you have to have a culture and have an incident response plan to deal with the ransomware attack and be able to get an understanding of what systems have been affected. Obviously, very simply, make sure all of your critical systems are backed up before that happens. But yeah, I mean, I think I think when you've already been cyber attacked, you really just have to make sure you have a really good plan in place to responding to that incident. And then I see another one here. What are some of the methodologies that can be implemented? No, I'm sorry. Given an organization, let's see. What are some of the methodologies you've been implemented for cybersecurity when an organization has many different contractors? Okay, so yeah, from our perspective, one of the things that when you have different contractors is, and that's kind of the way we do things in terms of our connection profiles to these assets. So if you have, let's say, Siemens or Schneider Electric or somebody like that, or ABB, you want representatives that are remotely operating those devices to only see those devices. So this really comes down to separating a group of users for each of your vendors, and make sure that you assign that group of remote users for your OEMs like that, your third parties, to connect to only their assets. So when you're giving them the right to authenticate and access their systems, they're not seeing other systems. They're only seeing the systems that they need to access. So that's a key thing. That's also, a security segmentation from allowing any sort of east-west movement of being able to move from system to system. You only want them to be able to access the systems that they're responsible for. So yeah, it's just really about setting up the permissions and only assigning the connections to each, at each vendor's asset that they need access to, and not others. So
Yeah, thank you. I think that suffices the question. So
yeah.
we will wait for one more minute if
Yep.
audience have some questions for you. Well, there's a question from one of our audience. How to deal with a suspicion that your IT contractor who has virtual control of your system is not working in your best interests? Bill, are you there?
But then, can you hear me?
Yeah, I can hear you.
Oh,
Actually,
okay,
we have
sorry.
some more questions from the audience.
Yeah, I'll jump into this one real quick on the suspicion. Yeah, so you do want to be able to kill the session, and then the way we do that is if there's something suspicious going on with virtual control, is have a kill switch to kill the session, and then that automatically would lock out their account and their ability to connect into the system. So this is another thing for safety. Obviously, this could be either suspicious, or it could be just somebody that's going to patch a system and they don't realize that there's safety implications of doing that in the OT network. So you want to be able to have that kill switch to stop the session immediately, lock them out, and lock their account as well, so they can't log back in. So that's the way we do it. What's the next one? I'm sorry. Should paying a ransomware be part of the organization's incident response, or is that not recommended? Yeah, this is a very difficult question. I think it's it really comes down to the organization. My personal belief on this is that you should not pay ransomware. But again, you have to really look at you would call law enforcement authorities and things like that would be the first thing you would do, and obviously try to get a handle on how many systems are infected and what the overall operations. But the default should be not to pay the ransomware. Understood that this could be costing a lot of money in your operations to unlock certain things, and this is why obviously we recommend a strong incident response plan, strong visibility and controls from a cybersecurity perspective, and system backups of your critical systems. So what are some methods to determine? Yeah, I mean, what are some of the methods to determine if your organization has good cybersecurity? I mean, there's a couple things that you can do. You can hire somebody from outside to do a security review of your organization and kind of look at potential vulnerabilities or architectural issues with the way your network is designed. You may want to think about potentially hiring a pen tester, penetration tester, somebody, we call that in DoD is red teaming, but yeah, so somebody to actually try to hack in, that's friendly to see some of the exposures there. So those are a couple things that you can do. But I think the key thing is to do a full security review. Make sure you know where all your systems are. You have good asset discovery. You have a good understanding of everything that's in your network, and have classified what your most critical applications are. Things that you must have running to operate your business. So those are the things that just kind of the basics. But yeah, I think both of those would be good. Okay. Let's see. Is there any way of preventing? You want me to go on here with this next one? preventing a data download internally and onward distribution. Yeah, I mean, that's a difficult thing to do without. I mean, the way that we would do that is not allow, if you're talking specifically about a system that's being protected from us, from a remote user, we would just simply not have the ability to have file transfer turned on or bidirectional file transfer turned on, right? So, you would have something where you would have, if you needed files to get in the system, you would just have a unidirectional file transfer capability to those particular critical systems or assets. So, there are tools there for analyzing and for protecting against, data being downloaded internally as well. I mean, there's other cybersecurity tools out there that you can do that for data governance and so forth. But yeah, from our perspective, it's really just not allowing the file transfer to happen.
Thank you so much for answering all the questions, Bill. I think there are no more questions coming from the audience. And we really appreciate you sharing such an insightful information with us. Thank you so much. Thank you so much.
Okay, thank you very much.